Good evening. I would like to welcome you all because this is the Civil Engineering Sectional Committee organized this one for ISL, and Mechanical Sectional Committee also helped. I like to tell something about the background of this program. We know the port city is very hot topic, not now, before 3 years ago. Sometimes I can remember one, not a professional one, politician said, මොකද්ද කිව්වේ ලංකාවේ තියෙන කළු ගල් ටික ඔක්කොම ගෙනාවත් මදි කිව්වා මදි වෙයි කිව්වා. ඒක වැඩි කරන්න. That was the incident before 3 years ago actually. That time several professionals there was not good discussion at that time. Later anyway there's some decisions happened and again the construction project started. Now this request came from especially from Soil Tech, you know, the one engineering consultant geotechnical firm. The team of Soil Tech has done some study because they have a lot of data in this area. So they have done some study and they came with a request to there's some problem with this project. So if you give a chance to expose this problem, and that will be a good opportunity. Then we discuss our ISL and our team. Then we decided to give a chance to them, especially Soil Tech people led by one senior geotechnical engineer, Dr. Karunaratne. He has several experience in this area. You know, not only the Sri Lanka, in foreign even. He's a geotechnical engineering consultation and interpretation of instrument readings, analysis and report writing. A lot of geology and ground investigation, geoslope computer analysis. There are several very big list under his name. So I'm not going to tell all of here because I need to give maximum time to them. And this is to actually for learn and discuss. If there are any problem, I can see a lot of geotechnical engineering in audience. We can discuss if there are anything. We can decide what as ISL and as a civil engineering section as a professionals what we can do in future. If there are any problem is there, because this is our responsibility, I think, as a professional to discuss these things and act if any problem. So with that, I like to invite the team of led by Dr. Karunaratne and the team to conduct, I think, according to the agenda, about 45 minutes, and after that the most important part will be the discussion. So I would like to invite Dr. Karunaratne and team to stage.
Thank you so much, sir. My special regards to Mr. Lalit from IESL for giving us this great opportunity to conduct this presentation with you all. But once again, good evening, ladies and gentlemen. On behalf of Soil Tech, I would welcome you all for this presentation. So before we start this presentation, I hope all you all know and well aware about the topic what we are here with you all today. But I would like to highlight what's the reasons which made us to do such a research-based study. So the presentation is headed with the Colombo city safe. Of course, this presentation is focused about the Colombo city, what we're going to do to protect the Colombo city. So this research is assumption-based study. So basically, due to the recent quarries and also the sudden changes in the groundwater, which indicates us there could be a significant change can happen in the Colombo suburb area. So which made us to do this research, to go for the deeper study, to find out the reason, what's the changes for these water levels. So basically we have done this research with the 2 decades of hand-on experience in the as a geotechnical in geotechnical industry, and the well experience in the borehole and tube well projects. Not only that, we have done this research with reference of our in-house library and especially with the well support and guidance of our geotechnical expert, I would say Dr. G.P. Karunaratne, who he shares his extensive knowledge with us and in reclamation of coastal area reclamation projects in around the world. So at this stage, it's my pleasure to thank you, sir, for giving your well support to do this research successfully. Not only that, I would like to conclude my introduction by giving you a key message: the prevention is better than cure. So this presentation will be further elaborated by Dr. Also, at the moment, I am giving hand to my colleague Divomi. She will continue this by briefing you all some of the findings what we have learned through this research we would like to share with you all. So please keep on observing. Thank you.
Hello everyone, good evening once again, and here we're gonna share some experiences of our researchers and the investigations we have done basically regarding coastal land reclamation, but here mainly we focus about Port City land reclamation since as we all know, Port City land reclamation, this is a major project ongoing in Colombo area. So here we mainly focus and our researchers and all investigations were carried in these premises. So this is the site plan of the Port City area, and this is the aerial view. So in here you can see there are many the major buildings like Sri Lanka Navy headquarters, Old Parliament building, Ministry of Foreign Affairs, Colombo World Trade Center, and many more buildings as well as others smaller buildings. So we say they can be affected due to this Port City project. So how it goes to affect? So if I say about the Port City project, this is the Port City area and the total land area is about 269 hectares and already about 56% has been already reclaimed. And for this we are going for a geological analysis, and with that we are going to present our assumptions and the possibilities whether things can happen. This is the impact of reclamation on groundwater level. So let me explain this. Here you can see that is the existing water table or the groundwater level. And we say with the researchers and investigations we have done for about 6 to 8 months regarding this Port City reclamation, we say this kind of thing can happen. So what happened there? This is the existing water table and the blue line shows the water table which has risen due to the land reclamations. So with that we say due to this land reclamation, basically the Port City land reclamation, this kind of thing can happen. What is it? The groundwater level can rise up to some meters. So with that some impacts, some effects can happen. And our research or these assumptions all are based on this groundwater level, the data we have collected and the subsoil data. So considering the Hartal Bridge Colombo Port, we did some boreholes there in 2017, the most recent one. According to that, we found in port area you can find groundwater level as 3.9 meters below the ground level. And the second one is railway bridges at Colombo Port again. So there we found groundwater level at about 1.2 meters below the ground level, and in some places we found it as 3 meters below the ground level. Another borehole in SAGT Colombo Port. the groundwater level was about 2.7 meters below the ground level. And Colombo dockyard. So here we did some boreholes as well as tube wells. In borehole we found the groundwater level is about 2.2 meters below the ground level. And the most interesting thing in here, we found the salt water interface about 24.3 meters below the ground level, and in here 21 meters below the ground level. So up to that extent, in our tube wells, we were able to find fresh water. These are the tube well data we have collected from Colombo dockyard. So with that, this is the graphical illustration we show about the groundwater level and the seawater level. So here, you can see there are 4 tube wells, what we have done in dockyard. So there we have groundwater level. It changes between 1.79 to 1.9. It slightly changes, but this is the salt water interface. So up to this extent, you can find fresh water, which are more consumable. And this is what we have shown with the impacts or the graphs that I have shown. So here you can see these are the groundwater levels, and here you can see the salt water interface. So here you can find some mixed water, but up to some extent you find fresh water, even it is closer to the coastal line. So this is the distance is about 60 meters from the coastal line, but you find fresh water. That means you have much considerable groundwater in port area. And the other thing is Gulf Face tube wells in 2004. So these are the tube wells we have. These are the tube wells we have done in Gulf Face. They are much closer to the coastal area, but there are 4 wells. The distance is about 30 to 70 meters from the coastal area. Even that much closer we found fresh water. These are the tube well data, and with that, with the chemical analysis, basically the electrical conductivity of water, we found they are good fresh water which are more consumable, and the seawater level we found at about 16 meters below the ground level. This is the graphical illustration of the water levels of Gulf Face area. So in here, up to this extent, you find fresh groundwater. This is the tube well again. So here you found at the bottom of the tube well, you find the salt, the mix, the salt cell and water. But here, up to 16 meters, you find fresh groundwater. The second part we did was subsoil data analysis. By using this subsoil data analysis, by using the boreholes we did again in Hartal Bridge, using the SPT values, we calculated using the Tazagi the bearing capacity. So in this graph, it has clearly shown in the red color line, you see the bearing capacity when the groundwater level is 3.9 meters below the ground level. That means that is the existing ground level. So, and in the blue line, it shows the ground when the groundwater level rises about 1 meter, what happens? The bearing capacity reduces from a considerable amount. So in here you can see the bearing capacity is 8047, but here what happens when the groundwater rises by 1 meter, it reduces up to 4828, a considerable reduction. Here we again calculated the bearing capacity using the SPT values with the boreholes we did in Colombo dockyard. So here again we calculated the bearing capacity, and it has shown in this graph. So see in here how much the bearing capacity reduces. That is just after 1 meter of a rise of groundwater level. And here SAGT, South Asian Gateway Terminal, Colombo Port. Here again we calculated the bearing capacity, and with all these data we can see with the rise of the increment of the groundwater level, definitely the bearing capacity reduces. And we have more examples around the world. Not only Sri Lanka do this kind of land reclamations, but Hong Kong, Japan, Netherlands, Singapore, they have done this kind of reclamations. And the Changi Port, this is a very good example from our Dr. Karunaratne, since it is a very good experience of him. So this is all based with the coastal reclamations. So now here we are going to mainly focus about the impacts, what can happen when the groundwater level rises. So there is a possibility to affect for the structures and buildings, what we have mentioned in the previous slides, like BOC headquarters, Sri Lanka Navy headquarters, all Parliament building likewise. So the structures and buildings basically on simple footings can affect due to this, and the buildings on piles also can affect to this, but they are much more safer than the buildings on simple footings. So what happened in here? The basic thing that can happen in here is the settlement. So due to the settlement, cracks can occur. So if the buildings get cracks, the walls or the floor get cracks, you can just simply assume that is due to the settlement. So if it is a uniform settlement, sometimes you will not feel it for some years. But if it calls for a kind of differential settlement, definitely you will get cracks in floors and the walls. And not only the buildings, but the other tunnels and chimneys and towers, those all can affect due to this. And considering the basement, in this graph, it has clearly shown, so here, due to the cracks occurs, the floor cracks or the walls, it can leak the water to your house or the building. So due to this hydrostatic pressure which occurs, some leakages can happen in here. And also the steel reinforcement, they can cause for corrosions. And the heritage buildings, sometimes they can cause for an undesirable settlement. And there is a vulnerability for seepages and rodent attacks. Not only the structures and buildings, all the roads and pavements which are in the considered area can be affected due to this. Surface crackings, deep crackings can occur, and in here you can see there is a bump or the lungings at the bridge approach. So this is an example from Indonesia what had happened. So this kind of things also can happen. And the other one is underground services. It's like sewer lines, water pipelines, gas pipelines. These also can affect due to the differential settlement. What happens? Joint dislocations, leakages, cracks, those things can happen. So there are many examples of these kind of things. As an example, I took these from news articles, what happened in Tamil Nadu due to leakage of underground gas pipelines. This kind of disasters can happen due to that kind of a simple thing. And the other thing is the environmental issues. So definitely the water quality in wells get changed. So with that we can say there is something happening underground water level. So I invite Dr. Karunaratne to go with more details about this research, and thank you.
Good evening, ladies and gentlemen. It is very nice and sometimes nostalgic when you return after a long time And in addition to that, I met a couple of my own batchmates, which is very rare that I can meet. And what it means is that the rest of the people are not here, not in this earth, they're gone out. So it is Jati Jara Vyadhi Marana. But when we come back, sometimes we see very important changes in the country. Some are good, some are not so good. But whatever it is, I think as Mr. Palligam introduced, well, you can write 2 or 3 pages of a certain person's experience. Whether the experience is valuable or not is a different thing. But if there is anything valuable and if you can pick it up, well, that is the way the education progresses. So, as my previous speaker pointed out, with land reclamations, there are problems. Problems are that if the land reclamation is done far away in the sea, it becomes an island, you don't see its impact. But if the land reclamation is done adjacent to an existing land, there is a, as the hydrologians say, there's a backup or there's an effect. This effect is important for us to recognize. Those 2 members, you can come here and sit in front. So if there's an effect, I think as engineers we would like to know, is this effect beneficial or hazardous or not beneficial? And sometimes they may be kind of neutral, but still as engineers we need to know how far we can go with new projects. So I have had the opportunity to experience and then do some research on reclamations, especially in Singapore. When I went there, there was no Changi airport, and fortunately I was one of the consultants in Singapore to do the Changi airport reclamation, headed by the Port of Singapore Authority at that time. Anything to do with the coastal, the port has to do, just like we do over here a couple of years ago. One of my friends is Dhanapala Godage. He has been with the port for a long time, and I met him probably after 40 years. Fortunately, we could recognize each other without much difficulty. So when I was working in Singapore for reclamations, what was interesting for geotechnical engineers was number of things. One is that how do you reclaim something so that the water in the sea can be moved away is one thing. Because now you are talking about 1976, quite a long time ago. We didn't have the technology that we have today, not electronics, not mechanical engineering parts, even electrical engineering is little. Imagine 50 years ago, all the engineering are much, the less sophisticated than today. Today we have, if you are an electrical engineer, you always have a connection with the mechanical engineer and civil engineer. So it becomes a kind of a joint effort when there is a project. Now that's how the long time ago the civil engineers started and then became non-military engineers. You remember about the Brunei, etc. in England, they were the civil engineers. The civil engineers used to do electrical, mechanical, civil engineer itself, road, bridges, etc. Then who are the other people? The military engineers. What is the action that they are supposed to do? There are some more seats over here. If you like to come over, you can come over here. So the military engineers did what the civil engineers don't do. What they want to do is immediately take some action to help the army or the navy or whatever it may be. So we had civil and electrical engineers. So coming back to this reclamation, so we had some problem with reclamation. One is about the consolidation of the seabed clay, and the second problem was, for me, the Singapore being a small island about the size of the greater Colombo area, it had to consume all the sand within its territorial waters to reclaim the Changi airport. So the government gave small sum of money to do research. I remember something like 1,000 Singapore dollars or 3,000 Singapore dollars, and one came for $3,000 to do research in hydraulics. So I went and told the head of the department that what is important for Singapore now is not hydraulic engineering research, but geotechnical engineering research. Why? There was no more sand to expand the country. So then I got into doing reclamation using seabed clay instead of sand, because seabed clay doesn't belong to anybody. You can go to the sea and then pick it up, the clay, nobody will bother about it. So the part of the reclamation research I did was using seabed clay, how to make land. And I'm not going to talk about it anymore on that, because now we have to go to the directly to the subject that we are working with. So Port City reclamation is an adjacent reclamation that we are doing next to the Fort area or PETA area, or at least the Colombo city. So we are trying to find out the influence of this reclamation on the groundwater in the adjacent area. I thought the adjacent area is the most adjacent, or the nearest area is Fort. So therefore let me just go on to the subject, and this was shown earlier, the plan and view of the Port City office as shown here, and then you see the breakwater going over there, and the part that we are worried about is in plan is the reclamation over there. Now, if you look at this yellow bounded what you call multigonal area, this side, on the eastern side, it is bound by the port water and the canal that is going from there to the Bere Lake, and this side is the Bere Lake and outfall. And then this is roughly parallel to the Chaitya, the road, Chaitya road, and Chaitya is somewhere here. And then you get the naval base and other things, and then this is part of the reclamation that's done there. So if I go to the large scale map of this, here is the Colombo Port City office, and this is the Chaitya road, and this is the water body that's coming from the port area towards this, and some of you may realize that, or you know that there is a gated connection here. So the water from here to there can be sometimes different. And then from the Bere Lake, it comes over here. Now our worry is, or our not worry, our study here is, when you do this reclamation adjacent to this Chaitya road area, what will happen to the water table in this case, because some of the work done by the soil tech, as shown by my previous speaker, had found that some of these boreholes and the tube wells, etc., have kind of a very remarkable way of varying its properties, especially the freshwater part and then the saltwater part. So because of that, we thought that we will study this as part of a kind of analysis first. So we have taken a cross section from there to there, and as you see here, this part is the reclamation, this part is the fort area, and beyond this water line, although the arrow extends, we don't worry about it, because the water, the boundary is controlled by the water in the port area, which is part of the sea, and the Bere Lake and this part. So what we have done is, we don't have enough information about the contour map of this. With the help of the Google Earth, available I think early 2016 or 2017 here, we picked up the elevations along this yellow line and then started making a study with respect to the groundwater condition. Now the software used is the Geoslope version 8.16 or 2016, and as you see here, as engineers we can't study everything very accurately right from the beginning. So what we have done is made some simplifying assumptions and then get some ballpark values. Now we have assumed that there is a steady state plain flow regime from the canal area on the eastern side towards the west where the reclamation is taking place, and then it is going to be compounded by rainfall about 100 millimeter an hour. And if you remember, some of you may have read that special environmental impact study done by CECB. They mentioned that the rainfall in Colombo area can be between 50 to about 175 millimeter per hour. But to my surprise, the last few weeks, and you probably would have experience, the rain can continue a couple of hours. It can be very heavy. So we took kind of 100 millimeter an hour and said that let's assume that it keeps on falling and it becomes therefore a transient steady state. It's not a fully steady state for our analysis. And then what we did was study the flow patterns, and then there are three stages we have taken into account. One is assume that there is no reclamation so far. Then what will happen to the groundwater table of the fort area with this intensity of rainfall? Then the next part is we studied reclamation with the same intensity of rainfall, but this time there is no internal drainage at the Chaitya Road. The Chaitya Road is supposed to have an internal drainage, but without that. Then the last one we have separated with the internal drainage, and I'm going to show you what happens if the internal drainage can be improved greatly with the analysis. And here the assumption made we have to make some suitable coefficient of hydraulic conductivity of the sandy soil and residual soil in the fort area. Some of you may wonder, where is sandy soil in fort area? Well, we don't know where they are. At least they are there close to the beach and along the Chaitya Road. So we are assuming there is sandy soil at the top. Of course, there will be residual soil followed by rock underneath. But I remember a long time ago, maybe 60 years ago, I did some investigation at CTB, the current CTB in Peta. The rock was not there for about 15 meters or something. So those who have done boreholes would know that where the rock level is very easily. Then we have a reasonably close hydraulic function is also assumed, which is the hydraulic conductivity of the sand. And then, as I mentioned earlier, plane strain flow is taken into account. Now, there are a few cases we have studied. The first case is no reclamation, no rainfall, there is drainage at Chaitya Road, and what will happen to the groundwater table. This is the base analysis. And we have got a value of 1.17. I'll show you the results. We assume the permeability of the sandy soil to be about 0.005 meter per second at 10 kilopascal, decreasing to 1/5 of that at 100 kilopascal. And subsequently, I changed this number to 0.5, which means that let's assume that the sandy soil is a little bit more pervious at 10 kPa, and these results I am going to show you. And then we put the reclamation, rainfall, no drainage, then the reclamation, rain and drainage. And I am also going to show you slightly more efficient drainage at the same location. Now here is a base diagram for this. Now as you see here, the sea is on the left hand side in this diagram, and this is the fort area along that yellow cross section I did. Now I wonder whether you can see that arrow. You can see those who are at the back. Can you see that arrow, or should I use the red light? Red light is better? Okay. There are some of you who are as bad as me with respect to eyesight, so I appreciate that point. Okay. So now this is, the only problem is I have to change my head that way to see that, so you may lose the voice there. So be reasonable with me. Now this has got a horizontal scale which is different from the vertical scale. As you know, the fort area is not that hilly as shown here, so I have exaggerated the vertical scale, and the horizontal scale, as you see from here to here, is about 100 meters, whereas some of that is only 10 meters. So once that has been done, what is done here is, in the second diagram, simulate the sea level on the left hand side, and then use the existing groundwater table. What are the boundary conditions? On this side, this is that canal coming from the port area toward the Bere Lake. So we have a boundary condition which is about 4 meters high, and on this side it is the sea level. So that side is the sea level, and therefore you can see that the water table is going to go down. I mean, that is a reasonable assumption that anybody would say. and that is how it looks like. So I thought the software seems to be working if that's the case. So if you go to the next one, in the next one, what we have done now is on the left hand side, the reclamation is now fully operational, but there is supposed to be a drainage system there according to the project report. But I said, imagine that the drainage is closed or blocked. Then what happens when you get rainfall of 100 millimeter an hour? This is what happens. It goes up and comes down. Now the only question is, are you sure that it will rise so much? You will be surprised that the values I am going to show you are beyond imagination. But don't worry about the numbers. Numbers are not that important. Get the trend. That is what is important right now. Okay, let's go to the next one. Now the next one is, I am going to give you some result. This is the first one I got, 1.17, no reclamation, no rainfall, drainage at this, the groundwater table at 200 meter from the edge of the Chaitya road. So if I go back, 200 meter at the edge of the Chaitya road is shown here. Chaitya road is somewhere here, 200 meter comes around here. So it is quite close to this peak there. So I always get that point for comparison. You can take any other point as well, but that is good enough, I think, for our analysis. So if you get that, you can see in the second one, if there is rainfall, no reclamation, it can rise to 13.18. And 13.18 divided by 3 is about 4-story high. Not possible. So don't worry about the number, but it rises. That is the important thing to do. So the controlling factors, as you see, are permeability of the soil and the boundary conditions. So let's look at the next one. The next one says there is reclamation and there is rainfall, no drainage at the Chaitya road. It can rise further. And the next one is, if you allow the drainage to take place, it drops a little bit. Now I change the permeability from 0.05 to 0.5, it drops. That looks reasonable. So somebody might say, why don't you use reasonable numbers? So you have to try and see. That's what the engineers do. Try various possibilities and get some idea. So now we see very important thing. If there is a reclamation, if there is rainfall, if there is drainage, still the water table can rise. Water table will not stay at the same level without the reclamation, before the reclamation. Therefore, we have a problem. Will the water table rise? That will affect the buildings and other infrastructure within the fort area. That's what my previous speaker pointed out. So let's go to the next one. Now, this case is slightly different. I am adding the drainage there. As you see here, the trend is correct. It drops here, then it goes there. So within the reclamation, the water table rises here. And this is like Jaffna Peninsula. If you have a well here, you can take fresh water from there. But slowly it will go down. And it will go down, and sometimes it might become level with the sea level, and you might sort of absorb seawater level as in Jaffna Peninsula. So you have to be careful. But anyway, as you see here, if you have a drainage system, this can be controlled. Now the next one I am going to show you is, if I make it much bigger, don't worry about this triangular shape, these are analytical thing. If you make it much deeper and wider, that is the pattern that you get. So you can see we need to have therefore a sufficiently large or deep volume of water to be channeled away like a drainage. Why is that? That is because the continuity condition, the water that comes out here must get out this way. If you don't let it go out, it will back up or even to the other side, or this will rise. So it is showing both forward and backward analysis that is coming in. So that is what is called the analysis part. Now the observations is very simple. With all reclamation change groundwater condition in the adjacent environment, unless you are reclaiming and forming an island far away. With the progress of reclamation field, changing rainfall intensity, drainage provision and the sea level, they will alter, the groundwater level will respond correspondingly. Unfortunately, the groundwater level will not go down, but they will go up because you are blocking the normal path of the water that is taking place. Then the second is that it lies to the port or reclamation is lying to the west of the fort area geographically. The groundwater table of the Colombo fort area appears to be influenced by the proposed port city reclamation. We are not saying something wrong with the port city. We are only saying that if there is a reclamation nearby, then the adjacent ground in the mainland may have some, the changing water table. If the water table changes, what would be the impact on the rest of the infrastructure, etc. Now, with heavy intensity of rainfall between 50 to 175 millimeter hour, as I said, see SEIS 2015 report. If that occurs in the Colombo fort area, groundwater table is bound to rise. And my previous speaker showed you water table variation within the ground, and when there is a reclamation, it is found in your flyer on the page 2, with the same figure, and you can see the reclamation will cause the groundwater table in the main ground area, the fort area, to change, generally to go up. And the observation continued. Now what happens if the water table rises? Building settlement is a problem. If buildings are founded on simple footings, you know that the bearing capacity will be affected. And only way to handle this situation as engineers is to imagine that some buildings are having simple footings and they will be subjected to water table rise, and therefore we have to take appropriate preventive action. How do you take preventive action? You must know that some are having simple footings, not on piles. So we have to have a feedback system or get the information. Data must be obtained. So I'm going to look at those things here after this. Now, in order to support our idea, this author J.J. Jiao submitted this paper in Groundwater in 2001. He mentioned that significant increase in groundwater table, if the scale of the reclamation is great and the hydraulic conductor reclamation material is low, that can happen, which means that if the reclamation of the port city is a tiny one compared with the fort area, you may not get that much of an influence. So if they are about the same size, naturally one may sort of influence the conditions of the other one. And then the last one shown here is the reclamation may change not only the groundwater conditions in the coastal area and around the reclamation site, but it can also change other things within the main area. And lastly, he also mentioned that groundwater regime to a large scale reclamation should be studied. Why? Change the coastal environment. There are other things. I think hydrologian may come and say, because of this reclamation, our littoral drift has got changed, or the Kalani River mouth has got choked. I don't know. This may come up later. I'm not speculating at the moment, but it can happen. And then some of you may later find that somewhere down Hikkarua or even Gold Harbour or some other place, there are some chain reaction. They come with time. So each of these must be therefore kept in mind. If something is changing, keep in mind something is changing, and therefore see whether there is an influence from some of these things that are coming in. Okay, this is the same picture that was shown by our previous speaker, and what is shown here is the existing ground surface. That is the water table under rainfall, as shown here. And as you see here, when it meets the sea, there is a little curvilinear triangular area. This is very interesting. Sea has got seawater with something like 3% of salt content, and the fresh water, let's assume that there is no sodium chloride in it, but this triangular area has got in-between values. So because they have got in-between concentration of salt content, their density is different. So denser material will be at the bottom and the lighter material will be at the top. When the density is exactly like like that of the fresh water, it is right at the top. When the density is much bigger, it is over here, and when the density is close to the seawater, it is even approaching that one. So you can see, depending upon the density, I think that triangular area comes into the picture, and this has been established by this J.J. Geo using his analytical approach. So that's very interesting, because we have seen the same thing with the previous speaker when they were investigating for groundwater in boreholes or pump wells. This part was fresh water. Then you start seeing the the seawater there. Now what is interesting here is again that when you do the reclamation adjacent to this with no drainage, the original water table shown in red color changes to that one. So you can see it automatically goes up. Most of the thing is taking place here, but if you have a drainage here, you can actually control this new water table to a lower value. So there are various ways of helping this problem if it occurs. Now I'm going to quickly go through the bearing capacity. Now there's nothing to argue about what is the best bearing capacity equation. Doesn't matter. But I'm taking a simple one, what is called the Tesagi's bearing capacity formula. This has got three components for strip footings. There's one coming with NC, the cohesion part, then one coming with the surcharge part applied on the footing. The second one comes with the friction part of the material underneath. And as you remember, it has got a triangular part below the footing, and then there is a logarithmic or curvilinear part ending up with some wedge shape failure case. Now, what I'm going to do from this point was that these are the parameters that you normally use, NC, NQ, and gamma, connected with A, where A is a function of the friction angle. So I'm going to use as an example the friction angle to be for loose to medium dense sand as 30 degrees. So if I take 30 degrees for this, and here is the simple footing with a width B, and if it is sitting over here, and if this distance is more than 1.5 B, you know that influence of the groundwater table at level 1 has no effect. It's generally dry. But if the groundwater table rises to 2 or to 3, we may have a problem. That's what we are studying in this case. So if I take Q with this equation, the corresponding values for 30 degree, for NQ is that, and gamma is that, NC is that. If the water table is below 1.5 B, such as line 1, no effect. If it's at line 3, what happens is, if it is at this point, here you get submerged density, because the water table is letting the sand to go upward because of the submerged density. So that sand cannot sustain the load coming from the building footing. So because of that, that influence comes in. So the second and third terms will be affected, because the second term is sigma VH is now effective stress, gamma minus gamma W multiplied by the H. And if these two values are taken into account, I'm going to compare Q1 corresponding to line 1 and Q3 corresponding to the top one, line 3. See, Q1 is written like this, Q3 is written with these numbers, where sigma V prime, gamma minus gamma W. So once you have written down, subtract Q1 minus Q3, the common factors will just go away, we get up with this one. So you can see it's gamma W H times NC half gamma W N, this is NQ, sorry, this is N gamma 18.4. And look at the next set of results. Supposing I have got water table rising half a meter, 1 meter, 1.52, those numbers will tell you that you are going to lose 200 to 300 or 400, etc., depending upon how much you have actually got this water level rising. So water level rise therefore may be important in some buildings where you have got simple footings, not mat foundations, not pile foundations, but individual footing, whether they are strip footing or rectangular, square or circular footing, doesn't matter, they may have a problem. So keep that in mind. And what happens, this is approximate analysis, anybody can do this analysis. If you want to get 6 kilonewton per meter squared loading per flow area, imagine that you have columns at 5 meter by 5 meter, then the total load will be given by this on footing, and if you have a 2-story building, this will be double up. These are a very rough calculation, don't worry about, there may be structural engineer, don't worry about these numbers. And if you want to have a factor of safety, what are you going to do? I want to get 37.5 for single story building. With a factor of safety, it becomes 93.75. So I have to look for 93.75 kilonewton load bearing point to do my what you call footing. Now, if I have got 1.5 by 1.5 meters footing, divide this by that, I am looking for 41.7 kilopascal bearing capacity with a factor of safety of 2.5. Now what happens if there is a water table rise? We have a loss of bearing capacity of half a meter rise. There is a spelling mistake here. Rise above base of footing will drop 240 kilopascal. Now there is a very important question we have to ask. Do you want to subtract that 214 from the ultimate bearing capacity or working bearing capacity? Now I was arguing myself, when you have got negative skin friction on piles driven in soft clay, you don't subtract the negative skin friction from the original or the ultimate bearing capacity, because that is effective. If there is no ground settling around the pile, there is no negative skin friction. So likewise, this water table must be taken very carefully, not with the ultimate bearing capacity, but with the practicing part. I was trying to find out another example for this. A crude example came to my mind. I remember in 2005, I visited a few sites down in the south after the tsunami. Remember, there was a train going there. So the train was running with a high factor of safety, but the tsunami came, 5 meters of water hit on the train and the train fell. So are you going to put a factor of safety on tsunami, 5 meters? No. If you do that, the train won't go. So the train goes. So there are places where you have to use factor of safety. There are places where you don't use the factor of safety. Take the full force. It may be something like wind force. Do you want to put a factor of safety? Sometimes you have to do it based on the various, the codes, etc. But this is the way to analyze this. There is no hard and fast rule to say, use factor of safety on the water table. If you use factor of safety on the water table, what you say is, instead of it rising 3 meters, you say, oh, it's rising only 1 meter. Can you imagine that? It's like saying that you are living in the house, somebody says, oh, it's going to rise 3 meters because the calendar is rising tomorrow night. Then you put a factor of safety, say, oh, no, it's rising only 1 meter. But your bed will be floating the next day morning. So you have to be careful where to use it. All right, now let's come back this question. We were thinking about this earlier. You may have a full settlement, the building will go down, or differential settlement, the cracks will come into the picture. Or you have this same situation, if the groundwater table goes up, even if there are cracks leaking here, and if your base is very weak, if base was not designed for that, it will start leaking because the cracks are coming into the picture. Now unfortunately, to solve this problem, we must know the data right now. Does a building, let's say A, have a basement, or is the basement having a problem right now? If the basement is having a problem right now, if the water table goes up, naturally it will have a worse problem. So that's how we are going to look at it. Now these are the affected infrastructure as shown by my previous speaker. Building foundation, basement wall, floors, tunnels, surface drains, sewers, cable ducting, towers and chimneys, roads and pavements, and the bump at the bridge approach. And this picture was shown earlier, and this is very interesting. It's a very serious problem in places like Indonesia because they have reclamation here and there. But most important is volcanic soil like montmorillonite can expand during the rainy season and contract during the dry period. And I know there were what is the right word for that? Very dangerous driving condition where people go at night. They don't realize that the bridge is like this. That is about half a meter above. They go and bang on the bridge and they just die. fatal. I was looking for the word fatal crash. It happens in Indonesia because of the more volcanic activity there. Now, I think what I'm trying to say here is we have to have predictive action. That means as engineers we predict, oh, this building may have a problem because of the information we have. So all buildings, old and new, foundation need to be examined by a geotechnical engineer, foundation engineer and a structural engineer for safety. And then all buildings, particularly vulnerable material deterioration. There are buildings that are 200 years old, like Cargill's building. I think the old Parliament building is 1930s, not that old. But all buildings may have material problem, we don't know. So those have to be examined. Any building adjacent to roads, etc. must be inspected regularly, because without the knowledge of the owner, some parts may be collapsing and then falling on the pedestrians. Well, I think we are responsible to make sure that the pedestrians can walk safely. In places like Singapore and Australia, I think the owner is responsible as a third party to make sure that nothing falls on their head. So that's the important thing. And I think there is something has happened here. Don't worry about that part. This one is regular testing and checking groundwater. I think there is a space missing here. The water quality, regular testing and checking groundwater table important. And also the second one is the water now in the reclamation is controlled by the Berry Lake and the new reclamation field. And the bacterial action of the water quality is something that we have to look at. And the corrective action is something that one of my other speakers will be talking about. What do you do if you have a problem like this? If you recognize that this is the problem, we have to take action. I think I'm going a little bit slow, am I? Oh, I'm all right? Okay, now these are some of our famous but old buildings. Old Parliament building, 1930, according to a report in the internet, this building was constructed on piles, concrete piles. But one of my colleagues said maybe on timber piles, brought from Ratnapur area down the Kalani River and then through Berry Lake into the site. Anyway, this is a Republic building. It is of course 3-story building, as you see here, 1, 2, 3. So it must be quite strong. It may not be, even if it is on simple footing, it may be strong enough. So the water table may not affect that much. And then we have the Cargill's building built in 1684 and Miller's and Gafur building likewise. Now the clock tower is, you know that is 2 years older than Big Ben. How many of you knew that the clock tower is older than the Big Ben? None of you knew that. What is the reason for that? Well, Big Ben and this were installed about the same time, but there was no clock apparently, because the British had to have the war with the Canadians. So they forgot to put the clock there. Then about 10-15 years later, the governor's wife can ask, you have a clock tower without the clock, where is the clock? So they found that it was still hidden in the, wherever the storage was. So that's very interesting. When you read some of these stories, I think you can tell the other people. Okay, I'm going very fast with some of these buildings we have got. All Parliament, Presidents of the Queen's House, Dutch dwelling house, etc. And we can see the effect, whatever that we have got, but we don't have the full story of the foundations. So foundation engineers or structural engineers may have to look for these things. And this is another interesting thing I found, that all these buildings were done by Wakchi Marika Bas. He was the grandfather of Sir Rasik Farid. Some of you may remember Rasik Farid. And interesting thing is, Victoria Memorial Eye Hospital, remember the Eye Hospital Junction, the old building was done by him. I still remember that building, because we used to, when we were in Colombo University, we used to cycle from Thurston Road to Maradana Technical College. So we had to go in front of that. So that's what I say, it's nostalgia when you come back. Observation and monitoring. I think we need to do this. Casual observation with respect to infrastructure or superstructure be confirmed. So what do you mean by casual observation? When you see an old building and if you see a crack, it's a casual observation. But somebody must record that and then start studying. Will that get magnified, get enlarged, get the worsened? And the temporary or permanent the structures within the zones of ground water rise. need to be monitored. That's what is called monitoring. It can be simple one, it can be mechanically monitored one. And with the owner's permission, extent of the drainage, damage, rate of propagation and the groundwater change with time need to be monitored accurately. I think we have to get the permission of the owner to do this. Sometimes they may not give permission because there are problems. As you see here, reporting and decision making. After accurate reporting of the monitored data, decision is to be made with respect to the mode of ground treatment later. You have to go for the effective but cheapest method. And it will involve time, cost, access, surrounding structures, ground condition, and the type of defect and its propagation, etc. Now, corrective action is something that we have to talk about. What do you do? But whatever we do, we have to have a feedback system once we have done that. And then when we say that we have done it, and we keep on monitoring to see whether everything is completed or not. Now, I thought we should have a feedback survey. I mean, anybody can design this. Feedback surveys, if there's a building, you record the address, owner, contact number and various things. And some of the owners, of course, will not like it, but if he has a problem, he will say, okay, monitor it. And then, first time the defect is detected, then primary action, subsidiary action, then the name of the professional examined, structural engineer, foundation engineer, recommended action, satisfactory. And these are some of the things that we have to record. Age of the building, type of building, use, how often used, defect, services, subsurface, cracks, settlement, seepage, roof type, electricity, gas, water and various other things like that. Conclusion, I want to stop here because I think I have taken too much of your time. What are our conclusions? If there is water table adjacent to the ground, it could elevate as a direct result of the reclamation field. Now that is for sure, it's going to go up. Irrespective whether you have got a very efficient drainage or not, it will rise even few centimeters. That is going to take place. Then the worst scenario is when the maximum rainfall intensity occurs, like the last few weeks we had rain everywhere. And if that happens, like a cyclonic effect, the water has to get out somewhere. If we don't have the proper channel, then we may have a problem. Elevated water could affect shallow foundation. I'm not talking about pile foundation, shallow foundation, because olden days, all buildings are done mostly on shallow foundation. Then we have to make an effort to detailed survey of all structures within the fort area, in this case, so that it is beneficial to prevent and minimize major damage in such cases. Well, with that, I'd like to stop and then hand over to my colleague Gaini. She will talk about some example that I think the Soil Tech had done in the port area, how it was managed. Okay.
Thank you, sir.
Good evening everyone. So I am here to share some experience about SAGT project, that means South Asian Gateway Terminal project. So with that project I am going to explain something about ground modification to mitigation settlement. So this is the plan view of our project. So in that circle you can see breakwater, and these are some photographs that taken in that project. So the cement blocks are loose little bit, so that's why we came with solutions. So let me introduce what is SAGT construction. It's constructed on reclaimed land, likewise in port city reclamation using sand, and the suspended concrete deck is supported on tubular steel pipes, and also the slope formed with reclaimed sand is separated from stones about with geotextile, and the slope is protected from sea waves by 25 to 100 kilogram rock and the armor of riprap. And retaining wall is constructed at the edge of the reclaimed land on 300 millimeters thick gravel bed for the retention of fill material. Finally, this wall also supported the slabs which connect the suspended deck to the reclaimed land. And here you can see the cross section of our construction. So these are the geotextile and the reclaimed sand here, and small stones, big stones, and riprap. You can see clearly there. And this is the subsurface of our profile here. You can see depth of 21.40 meters. It's a dense sand layer, and thick boulders was encountered between 3.5 to 5.9 meter depths. So likewise you can see the subsurface using this diagram. And let me tell you about what are the problem we encountered. So settlement, the main one is settlement and the lateral movement of the pavement surface, and the second one is the lateral displacement of retaining wall at the edge of the pavement. So here you can see some photographs here. Groundwater comes up like this and loose bricks and like this. So these are the some problems. And let's move on to reasons for the failure. The main reason is this: geotextile is damaged during the placement, and underwater it would permit sand flow into the open sea. So in the construction period, the cranes are all going and working with this. So that's why this is happened. And remedial measures. So here we choose if we want to do non-destructive methods or destructive method. So according to the results, we choose non-destructive methods, and we suggest 3 methods. The consolidation grouting, all 3 are grouting. But why these 3 parts? Consolidation grouting below the geotextile, and compaction grouting under the pavement, and finally jet grouting under the retaining wall foundation. So likewise we divided it to 3 sections. And we propose angle grouting as well. In here the angle of grout hole is 30 to 60 degrees. It's not 90 degree, it's angled 30 to 60 degrees, and the diameter of grout hole is 80 millimeters, and hole spacing is 1.5 meters. So these are the material compositions. I just skip this one. And these are some descriptive about jet grouting. I think you all know this, so I will skip. This is the rough diagram about what is the method of jet grouting, and this is compaction grouting. You can see in the slide, just a description. And these are the visualization of our grouting process. So here angle grouting, so these are the grouted ones, and here you can see the riprap, geotextile, and the retaining wall. This is the sea level. This is the visualization of our grouting process. So after this process, we tested SPT. We got SPT values after and before the construction to verify it. So these are the results to the verification. This is the graph, and finally this is a video. You can see. You can see the pictures that we taken while doing construction. Okay, that's the end of our presentations. Now the presentation is open for discussion. Thank you.
I would like to invite Dr. Karu to come to the podium and if you have any question, I will pass the mic. You can raise.
It's the sand field.
The hydraulic conductivity is very high.
Hydraulic conductivity is high in sand.
Is it correct? Because it's not this triangular edge which will transport the original ratio. The hydraulic conductivity is very higher.
Yeah, you're talking about the triangular area, right?
I mean, finally the water level,
Yes.
the seawater level will be back to the original because of the high hydraulic conductivity of the sand.
Well, I think let's go point by point because I'm trying to understand the question. If the reclamation is made with, can you hear at the back? Yes. If the reclamation is made with sand, sand permeability is generally high. And they usually use coarse sand, not very fine sand. Coarse sand. Coarse sand is the permeability is higher, or conductivity higher. Now, I think your question, if I understand correctly, is the original water table will rise, but if you ask the question whether the triangular area between the fresh water and the salt water moves toward the sea.
No, I mean the original water table will remain the same because after some time it will not shift.
No, it will,
Yes.
but it will not rise. It will rise.
The point will, because finally the sand area will be almost at the same as the sea water.
No, there is one point. Right at the sea, if the sea is on the side, sea level is assumed is constant. So the water table has to come from the ground level to that sea level. So because of that, the water table will rise.
It will not if the conductivity, if the hydraulic permeability is very high. With the time it will be back again at the original case.
No, whatever the permeability is, the gradient of the water table depends on the permeability. It depends on the permeability. If you have got, let's say, a very large storm, water will go very fast. You won't even see a groundwater table. But if you have got sand, as they use, coarse sand to medium sand or a little bit of fine sand, then there will be a groundwater table because that permeability is obstructing the free flow of water. The moment you have an obstruction of free flow of water, water table has to go. Because otherwise it can't create the potential. For the flow to take place, there must be a potential. And the potential is created because of the permeability. So I know your question is, if the coarse sand is used in the reclamation, isn't the conductivity or permeability high, and therefore shouldn't the water table remain the same? That is the question, right?
Yeah, it is almost the same.
Well,
Maybe a minor.
well, it may not, even if it rises 1 centimeter, what we talk about is correct. Moment you have a long way for the water to go from the port to where is a ground boundary to the sea, now very far it can go. Water can reverse. Assuming it's identical conductivity. So you have a point. If the reclamation is made with coarse sand, it may not have the same gradient as it happens in the fourth area, because sand has got a higher fluidity. I didn't take that difference into account in this case. So the water level will drop, but in the fourth area it will rise, because that's backing up. But it can be reduced if you have got the high-road drainage running efficiently. If that gets blocked due to bad maintenance or something, then I think the water table will start coming down. I think you have a point there. Thank you for that. All right.
Sir, the port city reclamation will cause a water table negotiation adjacent mainland. Is that what I understand?
I'm sorry, can you?
I'll say it's right. The port city reclamation.
Yes.
The port city reclamation will cause of the water table alteration in the adjacent mainland. Do I understand? Is that it's taking place?
Yes.
Yes.
That's what we say.
Yeah. So if that is, then should that be included in the environmental impact assessment that has been made?
So your question is there an environmental impact on that?
Yeah.
Because of the rising water table?
Yeah,
Yes.
this is an important aspect that you have just mentioned.
Yes, yes.
And should it not be a part of the environmental impact assessment on the port city construction?
Are you asking me whether the
Now, what do you think, sir? I mean, you said one thing that, the reclamation adjacent to the mainland will cause an alteration in the water level.
Yes, we are only talking about the water table, so it will rise.
That will of course affect the buildings.
Yes.
Yeah, so should this be taken into consideration when they are making the EIA for the port city?
Well, I hope they have done it. I'm not aware of whether they will do it or not.
Yeah, because they're on the 13th of December, they have asked for a new EIA on the port city. So the point that you mentioned is really very impressive, and I really thank you for it. And thank you.
Thank you.
I have a question actually. Now, for me, of course, rising of the water table is very clear, because the formation of the port cities was considered as an island.
Can you please repeat again?
Please speak to mic. Please speak to mic.
And then,
You have to realize that I may be older than you, and because of that, my hearing is little bit low.
my point is, for me, the rising of the water table is very clear, because reclamation is by the side of the joining land.
Correct.
But we should have avoided that situation by considering this reclaimed area as an island. In other words, there will be a channel which will feed the existing land and the reclaimed.
Yes, I think you have a point, that's what I said. If the reclamation is far away in the sea, like an island, that problem will not come to the fourth area. But there are other problems for the project development. For the reclamation in an island, in order to come to the mainland, they have to have a bridge or they have to have boat service. But they thought it's better to bring it close to the mainland so that communication is faster. So that's a different aspect of the project. But if the reclamation is near the mainland, what we are saying is that in the mainland, groundwater table is bound to rise. Does that answer your question?
Yes, absolutely. But I'm saying that particular separation need not be that wide. But this is, as you said, we need bridges. Because
Well, I think, yes, I think that we need a larger separation there. The separation can be 5 meters or 10 meters or whatever it is. You have to do a separate, more rigorous study to find out whether the water table can be brought within that canal to the same level as the sea level. If it is at the sea level and if the width and the depth is sufficient, then the water that comes from the fourth area will be channeled through that canal, so that the continuity of the quantity is maintained. If the quantity cannot be sort of balanced, and if the canal is smaller, then the water table will back up. So you have to have that what you call continuity condition of the water that comes into the canal, and the canal has to be round. So that's the direction. I think you have a point there. All right? Yes.
Thank you very much. Thank you very much for the thought-provoking and informative presentation. And I was just asking one of my colleagues what are these young girls doing in the front seats right at the beginning. They were doing an important thing, assisting you in the research and presenting the research findings. They are the future of the country. Nostalgia. Now, that is an important thing as well. The parliament was constructed with some sandstones or single stones transported from Tuan Valley. That was got into Ashley was the famous architect. Coming back to the question about the food city, whether there had been a proper scientific strategic environmental analysis (SCA) has been done or not, that is the question. These are important things that affect the entire nation, the entire coastline, the sea estuaries, the river estuaries, and also the groundwater table and river. The questions are whether any consideration has been given to the drainage of the port area, the channel that we're talking about, and if that is the case, is there a provision for that, whether it is a surface provision or underground provision? So these are the questions that are pertinent. Has there been enough in-depth analysis on these aspects, vital aspects, in the construction of the port city? It might not be the question that you might answer. It is a question that we as engineers in this country must answer. Because our ethics say that the engineers must hold paramount the public safety, health and welfare above their own interests, interest of their organizations and the country. So thank you very much for the presentation and for the Civil Engineering Sectional Committee for organizing.
Thank you very much. I think just commented that these statements are very valid. I think our job is as civil engineers or any engineer is to, for the benefit of the human mankind. And if whether anybody has done any study to find out the efficiency of the canals is, I'm not aware of that. I'm sure somebody would have done something, or if nobody has done it, it's high time to find out what is the most efficient width and the depth of the canal that has been maintained. But I remember seeing in one of the reports that they have a what they call another curvilinear canal coming from the northwest towards the southeast area. That is for the purpose of having circulation of water within the reclamation. All reclamation must have a water flowing through, otherwise stagnant water will cause a lot of problems, including mosquitoes and most of the reclamation in Indonesia, they have a continuous flow of water within the reclamation area. I think very well taken your comment, and I think that's what we should do as engineers.
Engineer Virat, I think you are enrolling it as a CCB, some sort of report in Port City.
Yeah, thank you. I think it's nice to see the presentation from the Port City with the these days are very much talking about. CCB is involved the expressed the part of the state of activity. And also the expressed is going with the lot of social and cultural systems. Both activities are very fun. At the same time, the GIF is too open for the public. It's very nice. But I think something missing there of my book is the study that we are presenting. One thing is Sri Lanka, Colombo. There is a project called Metro Colombo Project. That was running last year, it is called that was a feature in the fund. That was the very first time information we got it from the certificate and the water table institute. In Colombo and Metro Colombo, and especially the process in Bay, you don't want to worry about the process. The very big issues with the flood. The intense floods brings the water table and the water situation. That's the very first time information. If I don't have that information with the Google, you can very nicely, you have the water information. There are a lot of issues with the 0.5 to 1.5 inch difference in the water reservoir in the very common thing. Don't worry about it. So it's the critical. In Colombo, it's closer to the Bay, you have to the extent, but 0.3 meters below water. That means the Bay is a control lagoon. It's not, we are not allowing from just to flow, because we have to control the water in the That's the structure is not allowed. We are making the practical artificial. That's not allowed for a flood. So that is the area itself giving from our history, developed water table from the and another thing is this type of question. You can't just line first the longest line. This is a geographical unique. There are a lot of lagoons, three-dimensional study. Not the longest part for the take for the distribution of water, shortest part. You have got a perpendicular. Most of the directions are perpendicular depending on some situation. Why not crossing? It's because of the inlet flooding. So that was a major issue in Colombo. Not the compressed rise issue, other even the steroid issue. So very inlet factor. Because the steroid is now it's taken like 0.2 or something for the 20 years or something. But even doesn't go that much of it. But it's just flooding. So that is a major part of the moment. So really, think about water table issue in course. I don't think it's here critical issue. For my understanding and our data on the CC, there is a lot of information because of the information nearby Colombo board, all it was reflected. That's frankly telling. So we have the critical issue we came from the last year. We found that the water table, not the even water table, rises even falling. Much more critical than this. So that has to be taken care of. Even the last year, 2016, if you just go at the fragment, this is standard. You get the very good. You don't want water, but if the inlet flooding is high, then it's not controlled water. Even the extent of this land is not sensitive. It's a what it says, closer to the coastal boundary, it's like fluctuation, not inlet. Inlet flooding is a critical that's why observations and our present studies are really came up from the studies. So I think it is better to understand whether it will critically affect sports information going forward. That's a very critical issue. If someone can do it, it's a very complicated. That has to be very widely understood. Another thing is, you can't just plot the water table prices and fluctuation with the report without plotting the rainfall. So there is no meaning. So you have to match that. So it's the rainy period, you may have the different water table than the rainy. So because the report data is want to match it, want to study something, plot the rainfall data in that. Otherwise there is no point. That's not the research. If you want to talk with the water table, you have to be very much going with rainfall fluctuations and rainfall accumulations and also flooding, because we are getting not only the rainfall, so we are getting the tangible flooding and all these things are about water table fluctuation. So you can't just stop it. That's a very important point. Right? So with that, I have a very doubt whether it's 100% we can say this is true or not, because it's a very one-handed of thing. So we have to be collectively understand all of it.
Thank you for your comment. I think since there is no question, I think I will just add my comment. You are correct to say that very what level to control this one. At the same time, as I mentioned, it's a very rough analysis. If you want to do a proper analysis, you have a 3D program and do everything. At the same time, as you said, once you have done some investigation to find out what is the water level as an impact from the reclamation, those must be monitored at some particular places so that you can calibrate your observations and your analysis, etc. So I agree with that. But this is just to show you that if there is a reclamation adjacent to the mainland water table can be affected. It can be more than that. It can be slightly different from the point of view of the degree of effect. For instance, if the very construction for the water table is moved away from the current level, well, we have assumed at the far end the boundary condition for water table to be very lake valley, something like 4 meters above the mean sea level. Supposing it is different, then your water table will be different. So I think I take your point, what you mentioned. So this is just the beginning of what we take. And for one thing that what I think is that water table will rise because of the reclamation. Whether you have very efficient, the material in the reclamation or not, if the drainage in between by the side of the Shaikh road is not properly maintained or not properly designed, there may be some effect coming, whether you have rainfall little or not. But we are taking a maximum of 100 millimeter for this cost analysis, based on the impact study report, it can be as high as 175. If that continues for a couple of days, not weeks, but there will be some problem. That's what we feel from this analysis. But in general, what you said is very valid. We have to get these results, monitor the land, and then see whether our analysis is reasonably close. But if you want to do a 3-dimensional analysis, that is much bigger effort than this simple 2-dimensional analysis. Thank you very much.
Yeah.
There was somebody at the back.
May I continue on that to make an observation on that gentleman's observation as well? So if you look at the, your study is basically on the fourth area itself and not on the general Colombo area. And if you look at the map, it's there's delineated by the canal going from north to south on the side where the Untitled Bridge is, and the other canal that is going from west to east on the below the Parliament. So basically, it's a special area because the England flooding doesn't really affect that area because the water is taken out from those two canals. So you are left there with only with the reclamation plus whatever the other issues that we might have. Just an observation.
Yes, that's true. Those are boundary conditions for the flow within that particular area. You are correct. And those have to be taken into account accurately. Perhaps you may not have taken all those things into account, but that's a very valid point. Thank you.
I'm Ibrahim from Port City. We have a concern how long you are collected this data from which date for that research.
For the 3 boreholes that we showed?
Yeah.
Oh, they were done, some of them this year, and a few done, I think last year or so. Can you answer this? When did you do those boreholes? I think not very far away, during the last few months to few years, 2 or 3 years.
Actually, in this project, we have done the EIA and also SCIA, supplementary environmental assessment report. So, now onward, there is the environment management plan at site. So, we are monitoring these. We also engineer, we also now.
So, if I may ask you, do you have separate well points or?
Yeah, we have isometers in our site. We have not seen, noticed any significant changes so far. We don't know from where you are collecting these buildings are affected. So, in addition to that, if you see this drawing, along the Chaitya road and along the breakwater, there is a canal. It's around 10 meter wide and 8 meter depth. It is not directly connected to the original land. So, as you said in this diagram, this is not directly connected to our land. So there is a notch here. So we are not seeing this much of now increase. So in addition to that, if you see this diagram in my Port City project, there is an internal canal. There is also another canal along the perimeter, and there is another lagoon here. So this is not the ad hoc design. This is done by the Netherlands coastal and aircraft, and also the Royal Air reviewed this. So without collecting this design data, it's not fair to say this is have this much of defects or effect. So if we are ignorant, if the someone is done the research, he also did research. So you have to come and ask the proper person about the correct data. Without getting the correct data, it is not fair as engineers. We are not talking for or against. As an engineer, I also if something bad, I am saying bad. So without knowing, getting the correct data, please, I am learning a lot about presentation. Doctor, thank you very much. I learned a lot. We also study this because we are very much alert about what is happening, what is the environmental effect, what is the social effect. So we are alert. There are so many engineers from Sri Lankan engineers working at this project. So please, before conclude this, please collect the correct data and give your correct output.
Actually, this is not a conclusion. So we prepare the platform to discuss this matter. As a civil engineer section, as a ISL, we prepare the platform to discuss the matter if there are anything to take further. That's our idea.
Thank you very much for your comment. I think it's very valid. It's good that Hydraulics Institute in the Netherlands is actually had done a model and then studied the water, or what you call the circulation, and anything water body within the reclamation. And what is important, as you said, is if you maintain that canal between the mainland and reclamation, then I think that becomes more like an island, which has not much effect on this. But in case that canal is not properly maintained, then there is a problem. So that's what we are looking at. Now coming back to the observation, those observations may not have direct impact from your reclamation because the reclamation has not come up to any level yet. That's from my observation. But by the time it comes to the same as the ground level, and if you have some obstruction or some water flow is not there, then there may be a problem. That is the situation that we have actually brought forward here. To show that the reclamation, because of the adjacent reclamation, the water table within the mainland can go up. Not that it is going to go up if you properly maintain the canal. If there is a canal, of course, it's almost like an island, isn't it? Because there is no connection with the mainland there. So it is like an island having a separate issue. So that has a different paper.
Yeah, in our design, it is taken into consideration. So, in addition to that, what the baseline data, what is the baseline data you collect for this research? Because we have done some more project, we can check with the what is the ground water table, and you see that time. So please compare those things and
no, don't make a mistake here. We are assuming that your port reclamation will cause the problem in port area. We don't say that. What we say is that groundwater condition, water table may go up if that what you call the drainage is blocked. If it is not fully available as you had designed earlier. Because we have seen that if you have to do the maintenance of all the water bodies within the reclamation properly, then there won't be a problem because that's how you are designed. If there is a problem, like a blockage or something, then that can influence. That's all what we are saying here, nothing else. Nothing to do with anything against the reclamation. Sorry about it.
I want to get clarification from you. The thing is that the canal is you are going to be a reclamation canal. You are introducing some drainage pipes and you are going to connect to the mainland in the mainland. According to my knowledge, the mainland and now there is a canal separating a mainland and mainland. But we are proposing in future this canal part also reclamate introducing a. Are you sure?
I am thinking about more without knowing the data.
I asked. because I am working in a Colombo Municipal Council, you are proposing to take moment if your team is come to our office and they are introducing such a proposal. I think it is a wrong one, no? According to you, it is a wrong one.
I don't know who is contacting you. You have to contact
Now, you exactly the people who come from the Port City Development Company, they come and they say they are going to. I have this, all the data. They are these things are temporary diversion of the directorate road drainage because we have a certain amount of land. This land drainage is diverted to the sea directly earlier. Now they are proposing a temporary canal for the temporary purpose. In that, they are introducing a new proposal. Again, it is a semi-temporary one for 5-year period. They are laying at about 2,000 millimeter pipes along the road, along the in the canal path and reclaim it. And I asked them what are you doing on this? They are saying we are preparing a road and such thing. And in the future, after 10-year time, after 5-year time, there is a breach coming. After breach coming, the location is maybe different. They are introducing a permanent break. Business over. They are requesting our approval. Then you say it is a wrong and there is a permanent separation. Please clarify.
Thank you. We may know some background data. Actually, CNC is the road. There is a 18 outlet from Colombo to this camp. So CNC not allow us to cross it. So we actually this lane is at the end of the project, not the during the project we are constructing it properly. And so that is the condition. And also along the breakwater of the Colombo South Road there is a canal. We can't touch that area. So there is the actual data. So if you want, we can give the data.
So it means canal will be there, no, after project.
I'm sorry, we can't hear that.
Hello. Yeah, I am Engineer HRSD. I am the Deputy Director of Training Design for Municipal Council. We are responsible for taking all storage and stormwater network of Port City. Early proposal was there was a canal in between Colombo City and Port City. Now they are proposing to close that one and have a small lane. I thank to
Engineer Bimal.
One proposal. If it is so, we are very happy. We also want to have a canal in between both cities. One thing is true. They are trying to get the comment that the approval from us for closing the canal.
Dr. Asrik Karnathan, we would like to hear from you as Director General for NBRO.
First of all, I would like to congratulate Professor G.V. Karnathan because I knew him very well and one of the very well recognized geotechnical experts in the world. So if you go India for the number, so his student and his colleagues are there, so we are very proud of his work. One of the work he carried out is Southern Highway, I think all of you know, he was the man who started Southern Highway. So, and a lot of geotechnical initiation works. So, of course, I think going back to the subject, so I think the important thing is, the purpose of this lecture is to have a kind of discussion how the Port City affects the construction, how the Port City construction affects the surrounding environment. So, I think, of course, exact detailed design we can detail in some other forum whether it's as a canal or not, but what he has emphasized by having a canal, we can reduce the impact, right? That is what we understood. And generally, when there is land reclamation, downwater table will rise. So those are the four things. I think that is the eye-opener for the engineers, right? So we can work on that. And I think I thank for the general engineer from the authority as well as the CMC. This is a forum. So as engineers, we can discuss technical matters and the proposed government. What is need to be done to reduce the impact of this construction? I think in that purpose, this forum will, I think, very useful, and we can initiate this discussion further. And I think with that, I think as engineers, we can suggest what are the remedial measures to reduce the environmental damage. Thank you.
Yeah, thank you very much. Thanks, Rishi. And just thanking the chairman of the committee as well as Doctor. Can you take another same
of this discussion? We raised the questions on the certain impact that we can have. Can we have another session from the chairman? Maybe from the port speed part, how safety is something like, so that we give people hearing for problem. So another session followed up by this, as Dr. Asif said. Thank you.
Very quick observation again. Whether it is a drain as CMC is suggesting that the port city has asked for, or whether it's a proper canal that is coming down. From what I've seen, it's actually coming down from near the child here. So it's a slope towards the Bay outlet. So the issue here really is, and we can see already, the littoral drift is pushing the sand up to the Bay outlet now. So on a daily basis, Port City has been trying to clear the sand from there. But that is not going to be a permanent solution. It's going to be another Oluville harvest. People here know what the Oluville harvest is. Go see what has happened there. And I am seeing the exact same thing happening today at the outlet, at the Bay outlet in front of the Parliament, the Presidential Secretariat. So what's going to happen is, let's say there's a drain coming down or a canal coming down from the Chaitya to past Kingsbury to exact location where the water from the Bay comes out from the switchway. They're going to have issue with that sand building up below that water is not going to go up. So we are going to have a blockage there. And there is no proper plan or no proper idea up to now that I have heard that Port City has come up, or the CCD, the Coastal Conservation Department has come up to take away this sand.
Well, there is one more question to come. Before that, I have to say that I don't have a full answers or complete answers for all those questions. But if there is a littoral sand blockage that are going to take place, I think some of the Port City Declaration design engineers may be aware. If there is a chance that the canal parallel to the Chaitya Road is going to get blocked due to lack of proper maintenance, well, then I think you have a situation where the groundwater level will rise in both areas. That's what we are trying to bring your attention to. Thanks very much for everybody's comment and the questions. And thanks again, Dr. Asif because I knew him for some time back. So I think he's not saying thank you to me because he knows me, but he knows that the content is very important here. The idea of reclamation, the idea of the impact of that reclamation to a fourth area, if it is not properly done, will be significant. And as engineers, as somebody said, we have the what you call responsibility to be on the lookout for the what you call the betterment of the people around not only Colombo but the entire country with respect to the proper the studies. Okay, I think with that
there's one
comment. Okay.
One final comment from me, that is, I mean, there might be certain deficiencies in the methodologies and all, but this is a discussion and this is a forum. There is a lot more information that is available on the port side, on the CECB side. As it was stated, there might be the need to disseminate this information, because there is a lot of anxiety in the community. For instance, right now, for 100 years, the fault line in the USA that affects California area has not released any energy. For 100 years. Enormous energy is stored there. And the Californian state government has embarked on a program to strengthen all the buildings, because they know that a quake is imminent at one point or the other. So if that occurs, there will be a big calamity, loss of lives. So it is a proactive, preventive measure to be taken rather than wait for the earthquake to occur and to mount the rescue operation. We have the experience of the Uma wave that is being reported daily on the papers and on the media. So entire watershed has been drained, might be drained permanently. So certain things are not reversible. So we have to be mindful about this. So this is the need of the hour for the engineers to go out of their own personal interest or the interest of their employers sometimes, and come up and say, okay, I don't understand this, I don't subscribe to this. That professional integrity must be there in the community, and I think I'm sad to see over the 3.5 decades that I have been an engineer on and off, I see that is eroding very fast, the integrity of the profession. That must be restored. Thank you very much.
Thank you very much for that great idea. That will be the last question, yeah?
I want to thank you all. I'm not an engineer, but I'm very glad to be here, because you are the intelligence of this country, and the port is very important to us, and then we want to preserve our country for future generations. Thank you. Is it okay? Yeah. Engineers present here, you're doing great service to our country, and you have to protect our country. This is the small island with 21 million people, same as Australia, so we have to protect every inch of this country. What I want to ask you, sir, is this. This PM 2.5 and PM 10 particles that the port city would generate, the sea breeze comes straight over the city of Colombo. How are you going to protect the people of Colombo when you're building these tall structures on the port city? That's one thing to be considered. And the second thing that I'd like to ask you is this. Chinese people themselves, the environmentalists, were very concerned when they were building the port city of Tianjin. They said not to build a high-density city next to a transshipment port. Now, according to our Prime Minister, 83,000 people are directly employed in this port city, and it's right next to a transshipment port. Now, Tianjin exploded, and there was enormous loss of life and structure. Is this a safe thing to do here? Because we have an alternative. The alternative is this. You have, I think they said, reclaim 56% at the moment, turn that into a beautiful park and airline for the people, and use another area of 500 acres somewhere, and build the city and connect it by speed rail to the port of Colombo. That way, we will be saving our environment and providing our fishermen as well as the tourist industry with a beautiful island. We have to protect our island. This is just, it's a beautiful island, it's part of the Indian Ocean, and it's up to us to protect it. Other people may want to take advantage of our island, but we have to protect it and our people. That's what I have to say. And thank you so much for the information we've got, and you've been great, I learned a lot. I'm not an engineer, I'm an environmentalist, so thank you.
Thank you. So I want to add something to that gentleman, because as a civil engineering sectional committee and as ISL, we have realized that responsibilities. So not only the port city, not only the present project, for the future projects, even we will have some discussions, some forums we are going to discuss to have some maybe some like of steering committee within the ISL to discuss these matters and to because as a responsible person we have that responsibility. So with that, I think we can conclude for today, and there will be one workshop actually that is still not published even, and 12th about Umayyad. That will start at 1 o'clock and it will last about 4 or 5 hours. We are going to take all design engineers to this here. So our idea is කතාවක් තියෙනවා අස්සය ගියාට පස්සේ අර මොකක්ද වැඩක් නැහැ කියලා. එහෙම නෙවෙයි. මේ we need to learn, we need to discuss, and there will be more future projects in Sri Lanka. And as a professionals, that's our idea. There are a lot of events here. With that, I like to invite Engineer Asela, section mechanical engineering section chairman, because with this we organize as both mechanical and civil sectional committee. Asela.
Thank you, Engineer Lalit. Is Colombo city safe? Now discussion started. Actually, this is the main idea of aim of discussing such discussion in the ISL. This discussion not only limited to the this auditorium, but also you can later discuss this things, engineering related things, right? Now I am cordially invite Engineer Lalit Pallegama, Chairman of Civil Engineering Sectional Committee, to hand over the token of appreciation to today's presenter, Dr. P.G. Karuna Ratna. Thank you, Engineer Lalit. Now, first and now time for the vote of thanks. First and foremost, on behalf of IASL, I thank Dr. G.P. Karuna Ratna for accepting our invitation for today's lecture. It is an eye-opening lecture for us. Thank you very much, sir. Then I give my gratitude to IASL and IASL Secretariat for giving support to organize this event. Special thanks goes to Engineer Gamage, Chairman, Soil Tech, Engineer Kulatilaka, General Manager, Soil Tech, and staff of the Soil Tech Limited. Then I thank Civil Engineering Sectional Committee and Mechanical Engineering Sectional Committee of ISL for coordinating this event. Finally, I thank all invitees and guests who coming to this lecture for spending their valuable time. Thank you very much. Good night.